Welcome to the second half of chapter 5, and today we are going to talk about what happens when we don't have right triangles. So how do we solve triangles if they're not a right triangle? So the first thing we're going to talk about is called the law of sines. So the law of sines is an extended proportion that you're going to use to solve triangles that are not right when you're given angle, angle, side, angle. So any two angles of a triangle and an additional side, or two sides and a non-included angle. Okay, so the law of sines, like I said, is an extended proportion, and the ratio of the sine of angle A to side A is equivalent to the ratio of the sine of angle B to side length B, which is equivalent to the sine of angle C divided by the side length of C. And to kind of put that into a graphic for you, here would be a triangle. If I have angles A, B, and C, the sides opposite will have the same letter notation, just with lowercase, okay? So what happens in these problems is we are able to complete one of these ratios and use it basically like a key to unlock the other two ratios, okay? So there's some situations that occur when you're given two angles at all and any side. It's pretty easy to solve the triangle because you can find the third angle, right? So you have the triangle angle sum theorem. All the angles of a triangle add up to 180. Awesome. That's not so terrible to figure out. You can figure out that third angle and then you can use that to complete more of your ratios. But when you're given information, what you're given is one complete ratio. And what I mean by that is, for example, in the first problem here, solve triangle ABC, given that angle A is 36 degrees, angle B is 48 degrees, and side A is 8. So what I'm saying is that angle A and side A will complete the first ratio, and you're going to use that in proportions to unlock the other information in the other ratios. Okay, so I'm going to go ahead and draw myself a little picture because I really work best with diagrams. I'm going to set this up so that every time that I get an angle measure given and the side opposite given, I'm going to set it up in this orientation. So that way it's bottom left and then side opposite. So A equals 8 over here. Angle A is 36 degrees. And I'm going to say this is angle B. We'll let this be 48 degrees. This is side B, leaving angle C and side C. So what I had mentioned before about the you're given one proportion, in this case, we are given, in most of the cases, you're going to be given the A proportion. That represents this, or I'm sorry, the A ratio. So you have the A ratio right here. You can find the sine of 36 degrees. And obviously, you know A is 8. So we are going to use that ratio to unlock the other things. In this particular problem, what we can do really quick is we can already figure out what the measure of angle C is. We know the measure of angle C is 180 minus 48 minus 36. So that means the measure of angle C is going to be 96 degrees. Okay. When the problem says to solve a triangle, that means you need to find all of the missing pieces. Okay, so we need, in this case, to find angle C. Got it. We need to find side B and side C. Okay, so we have this angle, or no, I'm sorry, we have this A ratio. We have this in its entirety, so we can use it to unlock the other things. So the sine of A, so the sine of 36 degrees divided by 8. I'm going to use that to find side B. So I'm going to set that equal to the sine of 48 degrees, so that's angle B, over the side length B. Side length B, I don't know what it is, but I'm going to find it. Okay, I'm going to use some algebra here. I'm going to cross multiply. I'm going to get B times the sine of 36 is equal to 8 times the sine of 48. I'm going to divide on both sides by the sine of 36 because that's a constant. That is a numerical value at this point. I know exactly what it is. Those are going to divide out over there, and I'm going to get B is approximately 10.115. Okay, so I found angle C. This is done. I found side B. That's done. Now I have to find side C. And to find side C, Again, I'm going to use that A ratio that I know for sure, that sine of 36. I have a numerical value for this fraction. The sine of 36 over 8 equals the sine of 96 over C. Okay, so it's going to be the C ratio. So I'm going to cross multiply. Okay, so multiply by 8 on both sides, multiply by C on both sides. I get C times the sine of 36 equals 8 times the sine of 96. Divide both sides by the sine of 36. Okay, again, the sine of 96 and the sine of 36 are both numerical values. We know what their number is. We can type them into our calculator and get a value back. And please be careful how you type this into your calculator, BT dubs. Make sure that when you do 8 times the sine of 96, hit that and then hit enter, okay, and then hit divided by the sine of 36. Otherwise, you're likely to miss a parenthesis where you might need one, and then it'll screw everything up. Okay, so now you have everything. You have all of the missing pieces of your triangle. Yay, everything looks good. Okay, we've solved that triangle. So anytime you're given 2 angles on a side, doesn't matter which side, you find the third angle using the triangle angle sum theorem, knowing that all 3 angles of a triangle add up to 180. So if you know 2 of them, you know the third. Then you're going to use one complete ratio. Usually it's going to be the A ratio, okay? It might not be, but sometimes, most of the times it is. And then you're going to set that equal to, that complete ratio, you're going to set that equal to the other ones. We did B first and then C, doesn't matter what order you do them in, and find the other missing pieces, okay? So there is that. Now, what happens if you're not given 2 angles aside? Well, when you're given 2 sides in a non-included angle, side-side angle, which we know is not a triangle theorem, but it is a way to describe what you're given, it's complicated. There's some stuff that can happen. First things first, pro tip, I want everybody to get into the habit of doing this, and I want you to set your triangles up the way you're seeing them here. Always set your triangle up with this orientation for side-side angle. You don't have to do it this way for not side-side angle, but it's just kind of like a good habit to get in. It's the way I set all my triangles up, and you'll see why in a minute. Set them up so the angle that you're given, okay, so the angle that you're given, its angle measure, you're going to put that in the bottom left-hand triangle, a corner of your triangle. So here's your given angle. The side opposite obviously goes side opposite. So the letter that matches, uppercase letter is your angle, lowercase letter is your side. You want to throw these on your triangle like that, okay? You will then be given an additional side. I want you to put that side adjacent, above and to the left of the angle that you're given. Trust me on this. Just do it. Okay, it's going to save you a headache later. So you're going to set it up like this every time. Another thing that we have to do in these problems is we are going to have to find the height of our triangle. And to find the height of your triangle, you are going to take B times the sine of A. Now, I'm saying it's B and A because that's the way this particular triangle is set up. But here's the triangle that's going to allow us to find the height of the whole triangle. Right, so I dropped an altitude down from angle C perpendicular to side C. That's going to give me my right triangle here. The sine is the opposite over the hypotenuse. So the sine is h over b. So that means my height, if I solve that h over b, if I solve it, it's going to be b times the sine of a. Okay, but generally speaking, it's going to be your given side, this side right here, multiplied by the sine of whatever this given angle is. Okay, so this is part of the reason why I want you to set it up in this orientation. Now, once you have identified the height, b sine of a, you need to compare it to some things. So, if side A, as we have it set up like I have up here, okay, so you want to make sure you have it set up that way. We're looking at that. So the side that you're given that's across from the given angle, if that length is less than the height, you don't have a triangle. That piece of the triangle is not long enough to connect to the side of the triangle down here Your A, this guy here, is too short. It doesn't work. You can't make a triangle with that configuration. Okay, so that means if you have a problem like this and you find that A is less than your height, you have no solution. You don't have a triangle. There's no triangle. If your height and your side A length across from your given A angle, if those two things have the same value, then that means A is an altitude, which means you have a right triangle. Just use your right triangle stuff to find what you're missing. Okay. Now, if A is bigger than your height, and also A is bigger than the other side that you were given. So if A, this side over here, whoops, let me go back to my highlighter. If this side over here is larger than the height and also that side there, you have exactly one triangle. Exactly one, no more. Now, here comes the fun part. If your side that you're given is longer than your height, but less than the side that is adjacent to angle A, so this little side A is going to be shorter than B, but bigger than the height, you don't just have one triangle, you have two with that information. So the parameters that you're given could allow for two triangles, and this is called the ambiguous case of the law of sines, and it's called that because it's not clear what the answer is, because there's more than one. There's two possibilities. So that's why it's called the ambiguous case. So when we're looking at the ambiguous case and we're looking at this configuration, what you have is you have this side A that could extend out this direction, or that side A could extend in and create an obtuse triangle down here. Okay, so why does that happen? Well, I want you to think about this is the center of a circle and this is a radius. If I have my center here and a radius here, this will swing. Think about a circle. I have two radii that will intersect this line down here because it's longer than the height but shorter than that side B. So that means we got these two options, right? So basically what we're going to have to do is solve two triangles. The trick, though, is once you find the first triangle, I label everything with a little subscript of 1, so I know I'm talking about the first triangle. The second triangle, there is like a little hack to it. And the hack to it is that if I know what B1 is, if I know what that angle measure is right here, I know that this is also B1. Why do I know that? Because isosceles triangles. Because this triangle right here, formed by the two radii of that imaginary circle that I drew, these guys are congruent, right? So that means these are congruent because isosceles triangle theorem. So if that's the case, I'm going to come over here and I'm going to look, here is B1. That means B2 that is right here in the corner is supplementary to B1. So that means 180 minus the measure of angle B1 is going to give me angle B2. So the second triangle is going to go quickly because then we'll have two angles, but that's how we do it. Now, after hearing this explanation, if your head is spinning, I get it. This is a lot. So here's what I would recommend you do. First of all, pause the video, write all this stuff down, copy all these diagrams down. Okay, that's the first thing. The second thing, I'm going to go through a bunch of examples. Okay, so I'm going to go through a bunch of examples that show you how to do this. So please don't panic. I promise you, I am going to give you plenty of explanation. Okay, so here we go. We are given, in this case right here, we are given side, side, and an angle. So in this example, I have angle A is 30 degrees, side A is 6, and side C is 10. So I have two sides, side, side, and I have angle A. I'm going to draw myself a little triangle over here because I like a diagram. So here's angle A that has a 30-degree measure. I have side A equals 6, and I have side C. Now, it's not B this time, but I'm still going to put side C equals 10 over here. I still want the given side in that spot, okay? So that means across from it is going to be angle C. Let me take the one out of there. Actually, yeah, this is going to be C1. So that means this is going to be angle B1, and this is side B1. So here is the first configuration for my first triangle. I'm going to use the law of sines with this, just like I did before, and I'm just going to press on using what I have, just the same way we did before. So I have my complete ratio with my A information. Okay, so we're going to find, let's find angle C first. Okay, so I'm going to find the measure of angle C. So I'm going to have my ratio for my A, so this is going to be the sine of 30 divided by 6, there's my A ratio, is equal to the sine of angle C divided by 10. Okay, so we are going to cross multiply. I'm going to get 10 times the sine of 30 equals 6 times the sine of C1. I'm going to put a little 1 there because this is my first triangle, okay? Divide both sides by 6, and I get the sine of C1 is equal to 10 times the sine of 3 divided by 6. Oh, not 3. That should be a 30, shouldn't it? Whoops, 30. There we go. Okay, so how do we find our angle measure? That's when you do the inverse sine on both sides. So the measure of angle C is going to be equal to the inverse sine of this fraction, 10 times the sine of 30 divided by 6. So that means, all told, the measure of angle C1 is 56.44 degrees. Okay, so that's lovely and awesome. I can use my triangle angle sum theorem to figure out that the measure of angle B, so 180 minus 30 minus 56.44 is going to give me an angle B1 measure of 93.56 degrees. That's fantastic. I now have two, my missing two angles. That's awesome. So here's the measure of angle B. I found that. And now I just have to find side B, side B1. Okay, so you're going to use your A ratio again. So sine of 30 divided by 6. Always start with the ratio you're given, not any part of the ratio that you have found. So don't use the C ratio to find B because you found angle C, okay? Always use what you're given to find that information. So sine of 30 over 6 is equal to the sine of 93.56 over B. And I'm going to cross multiply. And I'm going to get B times the sine of 30 divided by, oh my gosh, what am I doing? B times the sine of 30 equals 6 times the sine of 93.56. Okay, divided by the sine of 30. And I divide these out, and I get B is about 11.98. Okay, so there we go. So we're done. We figured out that triangle. That one exists. That's awesome. But we have to test to see if we have to do two. Do we have two triangles or do we have just one? So let's figure out our height over here. I'm going to come over here. I'm going to drop this down. Here's my height. Okay. So my height is equal to, in this case, it's not B times the sine of A. So if I set up this original equation, let's just set up the sine of 30. So the sine of 30 is equal to height over 10. So my height is equal to 10 times the sine of 30. So that means my height is 5. Okay, so if I use that height is 5 information, I'm going to look at this ambiguous case. I'm going to look at all of these things. So A is bigger than my height. Okay, so option number 1, A is less than, nope. A is not equal to, A is bigger than the sine of A, yes. 6 is bigger than 5, but is A bigger than C? In this case, is 6 bigger than 10? No, so it's not one triangle. We do have the ambiguous case in this one. We are going to have to find two triangles. And that's because my height is in between the two sides that I was given. And my A value is bigger than my height, but less than the side that I was given. So that means I have to figure out what triangle 2 looks like. Okay, so just to make sure that we are here. So this is going to be 6. Now I'm going to draw a second triangle with the same information, but oriented differently. So I'm still going to draw this. This is going to be A. This is going to be B2 now because I'm in the second triangle. This is still 10, but now C2, I'm going to swing this arm into here like this, still 6, right? This is going to be angle C2. This is going to be side B2, okay? So now we have the second triangle with the exact same information that we were given. Got to throw my 30 degrees in there, okay? And now we have to find all of our other stuff. But one of the things that makes things a little easier on this is that C2 is easier to find, okay? And again, why is it easy to find? In this triangle up here, if I extend this down, and this is my 6 for my original, and I extend this side over, we know that this is an isosceles triangle. And if I know that this angle right here, C1, is 5644, that means this is 5644, but also that is 5644. So that means the measure of angle C2, since it's supplementary to 5644, is equal to 180 degrees minus 5644. Okay, so that means the measure of angle C2 is 123.56. Okay, so the measure of C2 is 123.56. So now, that's great. I have 2 angles of my triangle. I can find the third. So the measure of angle B2, using your triangle angle sum theorem, is 180 minus 30 minus 123.56 is going to be 26.44 degrees. And I'm good. All of my, like, that makes sense. I can have a triangle with these 3 angle measurements. Okay, the measure of angle B2 is 26.44. Then we're going to go ahead and put that in a box. Awesome. Okay, so this is triangle number 2. We found the measure of angle C. We found the measure of angle B in this new triangle. Now I just have to figure out what the value of B2 is. I'm going to use my A ratio, the sine of 30 divided by 6 is equal to the sine. I got to find my B, so I'm going to use my angle B, the sine of 26.44 divided by B, cross multiply. B times the sine of 30 equals 6 times the sine of 26.44. Divide both sides by the sine of 30. I'm sorry, I keep clearing my throat. It's got to be not cool to listen to that. I apologize. So B is about 5.343. Okay, so this is an ambiguous case because how do I know that I have to solve for 2 triangles? Because I checked out my height and I compared that to the information that I was given up above. My A value was bigger than my height, but less than the other side that I was given. So that means I am going to have 2 triangles. I am going to have this big triangle that's oriented this way, but then I'm going to have this obtuse triangle that goes this way. Okay, so there's your first example. I wanted to give you one that was definitely an ambiguous case before we do other ones where we're going to test to see what we have to do. Okay, so there it is. There's when you have an ambiguous case. All right, so the next one. Solve ABC given that A is 7, B is 6, and angle A is 26.3. Okay, first of all, we are given side angle, so that means I have to draw this out, and I got to test to see, am I finding 1 triangle, no triangles, or 2? Okay, so the first thing I'm going to do is I'm going to draw this generic triangle. I draw the same one every time. Angle A is 26.3. Side A is 7. The other side I'm given is side B. I don't care what the letter is, but the other side I'm given, I'm always going to put it in that position. That 6 is always going to go in that position. That is letter B, side B. So I'm going to let angle B be over here. So that means this is angle C and this is side C. Okay? So let's test, let's figure out what our height is. So in this case, the sine of 26.3 is going to be equal to my height over 6, because that's how we do with right triangle trigonometry. My height is equal to 6 times the sine of 26.3. So that means in this particular case, my height is 2.66. So this is 2.66. All right, so we compare this. My A value, 7, is greater than my height. My A value is also 7, is also greater than the side that I was given, which is 6. So in that case, we do not have an ambiguous case for this one. We only have one triangle here, because that A value 7 is bigger than both the height and also the other side that we were given. So we only have to find one triangle for this one. Okay, so proceed with your law of sines as per usual. In this case, we're going to have our A ratio. Always start with the ratio that you're given all of the information. Okay, so I'm going to use this to find angle B. Okay. So the sine of 26.3 divided by 7, that's going to be your all the time ratio that you're going to start with, because that's a value. Okay, that ratio has a value. So the sine of 26.3 divided by 7 is going to be equal to the sine of angle B over 6. We are going to cross multiply and solve. So I'm going to end up, when I do this, I'm going to get the sine of B is equal to 6 times the sine of 26.3 divided by 7. So that means the measure of angle B is equal to the inverse sine of that fraction, 6 sine 26.3 over 7. So that means the measure of angle B is 22.3 degrees. Okay, we got 2 of our 3 angles now. That's awesome. I can find the measure of angle C is super easy because of the triangle angle sum theorem. So it's 180 minus 26.3, which is my A, minus 22.3, which is my B. So the measure of angle C is 131.4 degrees. Okay, and then the last thing I have to do is I have to find side C. So use the ratio that you were given with all of the information. Sine of 26.3 over 7 is equal to the sine of 131.4 divided by side C. Cross multiply and solve. C is going to be equal to 7 times the sine of 131.4. Please put that in and hit enter, and then divided by sine of 26.3. And you'll get your C value is about 11.85. Okay. So for the next couple of examples, I'm going to do 3 more. I'm going to go through them a little more quickly. I am going to talk through them. If you want to listen to this at half speed, you're welcome to, or regular speed. Or if you are getting this and you want to just breeze through it, listen to me on double speed or 1.5. I don't really care. It's up to you. Okay, so I'm going to do, like I said, 3 more examples. So example 4, solve triangle ABC if the measure of angle A is 49 degrees, side B is 28, and side A is 32. Again, I'm going to set up this arbitrary little triangle here. A is given to me as 49. This is 32 across from it. Side B, whatever number I get next for another side, it's going in that spot. So 28 goes right there. It happens to be labeled B, so angle B is over here. Angle C, side C. Okay, let's go ahead and test for my height. So my height equals 28 times the sine of 49. So my height equals 21.13. I'm going to compare it. My A value is greater than my height. My A value is also greater than the other side that I was given. So that means I have one triangle. Okay, I don't have to go through all the craziness for this one. I just have to find that one triangle. Okay, so the ratio I'm given, again, is my A ratio, so I'm going to use that. and I'm going to find, let's find angle B first. It doesn't matter. You can find angle C. Okay, so I'm going to set up my ratio. Sine of 49 over 32 is equal to the sine of angle B divided by 28. I am going to cross multiply, and I'm going to 1, 2, skip a few to make this a little faster. I'm going to get the inverse sine of 28 times the sine of 49 over 32. I am confident that you can handle doing the algebra to get to this point. The measure of angle B is 41.33 degrees. To find the measure of angle C, I'm going to use my triangle angle sum theorem. So the measure of angle C is going to be equal to 180 minus 41.33 minus 49. So that's going to give me 89.67 degrees. Okay, and then I have to find side C. I'm going to use sine of 49 over 32. I'm going to set that equal to the sine of angle C, 89.67, divided by side C. I'm going to cross multiply and solve, and I get C is equal to the ratio of 32 times the sine of 89.67 when you cross multiply and solve for C, divided by the sine of 49. And I get C is about 42.40. Okay, so we solved our triangle. We have all 3 angles on all 3 sides. Next example, next to last one, almost done. Example number 5. Solve triangle ABC given A is 18, C is 10, and the measure of angle C is 30. Okay, so they're giving me letters in a different order here. That's okay. Put them exactly where I showed you to put them. If this is C, that's fine. Side C across is going to be 10. And I'm going to put the other side that I'm given right here, regardless of what letter it is. Okay, but that is letter A, so I'm going to put angle A across from it. So that means what's left has to be the B's. Okay, so we're going to figure out our height here. Height. So height is B times the sine of A, but in this case, it's going to be A times the sine of C. It doesn't really matter. Just think about the location. Think about this little green this little triangle right here. So you're going to take the sine of 30 equals height over 18. So the height for this guy is 18 times the sine of 30, which is 9. So what do we got here? So we have 10 is greater than my height, which is 9, but 10 is less than 18. So that means this is going to be an ambiguous case. I'm going to have to do 2 triangles here. Okay. So again, if you're not sure where I came up with that rule, that is going to go back to right here where we're testing these things. Okay, we have the ambiguous case. We have where our side A that we're given across from the angle that we were given is greater than the height, but it's less than the side that we were given adjacent to our angle. Okay, so awesome. All right, so I'm going to label this. I'm going to throw a 1 on here because this is triangle number 1. And I'm going to redraw for triangle number 2. Okay, so got it. Triangle number 1. We are going to use the ratio that we are given, okay, to find whatever else we need to find. So the sine of 30 divided by 10, because this is the ratio that we have complete that has a value. Now I'm going to pick what I need to find. Well, I can't find anything in the B ratio because I don't know the angle nor do I know the side. So that means I have to find angle A1 first. So I'm going to set up my A ratio. Sine of A1 over 18. Okay, we're going to cross multiply and solve this. So I'm going to 1, 2, skip a few. The measure of angle A1 is going to be equal to the inverse sine. So when you solve it, you should get 18 times the sine of 30 divided by 10. So that means the measure of angle A1 is going to be 64.16 degrees. Okay, using my triangle angle sum theorem, that means the measure of angle B1 is going to be 180 minus 64.16 minus 30, which is going to be 85.84 degrees. Okay, very good. Love that for us. Got all of our angles figured out. Perfect. So now we are going to figure out what side B1 is, okay? So use what you've been given, sine of 30 over 10. I'm going to set up my B ratio now that I know what my angle B is. So the sine of 85/84, and then divided by B1, okay? You're going to cross multiply, so B1 is going to be equal to 10 times the sine of 85/84, all divided by the sine of 30 when you get there. So that means side B1 is going to be about 19.95. Awesome. Found everything we needed. Lovely. Great. I'm here for it. But now we have to take a gander at triangle number 2. Okay, so we're going to draw it. Instead of having this side here, side C, out that direction, we are now instead going to draw it coming in this direction. Okay, so I'm going to draw my triangle again, but now I'm going to draw that side this way. Okay, this angle right here is now angle A2. This up here is going to be angle B2. This is still angle C, whoops, with a degree measure of 30. This opposite side still has a length of 10, and then side A still has a length of 18. So now we have to figure out what A2 is, what B2 is, and what 18, A2, B2, the angle, and B2, the side. Okay, remember that if I extend that out this way, I have angle A1, this and this are going to be congruent. So that means this angle right here is the same angle as A1. It has the same angle measure as A1. And angle A1 has a value of 64.16 degrees. Angle A2, which is this angle right here, is supplementary to that. So that means the measure of angle A2 is going to be equal to 180 minus the measure of angle A1, which is 180 minus 64/16. So that means the measure of angle A2 is 115.84. So the second triangles actually go pretty quick because now you have two of your angles without a whole lot of effort. Okay, so we can figure out what the measure of angle B2 is using the triangle angle sum theorem. 180 minus 115.84 minus 30 is going to give me the measure of angle B2 as 34.16 degrees. Okay, and now I have to find side B2, and I'm going to use my ratio that I was given. Okay, so to find B2, there we go. So I have the sine of 30 over 10 is going to be equal to the sine of 34/16 divided by B2. And I meant to make that a different color. See if I can do this. Style. What's up? That's so cool. If you didn't know you could do that on Notability, you can do that on Notability. That's pretty dope. Cross multiply and solve. So I'm going to get B2 is about 11.23. I'm confident in your algebra ability. It's the setup of these that I think we just want to make sure we see this. Okay, so again, you have your two triangles. You have triangle number 1 with that parameters that were given to you, but you have, just because the side opposite the angle you were given is bigger than the height but smaller than the other side that you were given, you have to consider the fact that there could be two triangles. Okay. I have one more example to go through with you, even though I have this here. I need to move it down. There we go. I'm going to go through one more, and this is going to be extremely fast. The measure of angle B is 88, side B is 14, and side C is 62. Solve triangle ABC. So I'm going to draw this out. Beep, boop, bop. I'm given the measure of angle B, so I'm going to put that down here, and I'm just going to label that with a B. 14 is across. I'm going to put the 62 up here because that's how you're supposed to put this all together. Angle C, angle A, this is going to be a little side A. So let's test our height. So here's our height and see what we got here. All right, so my height is going to be 62 times the sine of 88, which is going to be 61.96. And when you compare this, something interesting happens. This is the first time we've seen this. In this case, our A value, it's not A, but it's 14. 14 is smaller than my height. 14 is smaller than 61.96, so that means we have no triangle. But I drew a diagram. Yeah, I know I drew a diagram, but it was arbitrary. It wasn't to scale. I just drew a figure that is a triangle, so that way we had something to reference. That doesn't mean it's to scale. Okay? So there you go. If at any point you need to go back and rewatch this, I mean, obviously you can watch as many times as you want. It's a video. I will be back tomorrow. Ask me any questions that you have. Your homework assignment is page 484, numbers 1, 3, 5, 13, 14, 15, 27, and 28. I hope you have a fantastic rest of your day. Stay safe, make good choices, and